So today our project is about developing a conversational chatbot for enhanced customer experience using Palm. So we are a team of three people, and this is Prem Kumar Rasakonda.
This is Hanila.
This is Pavan Kumar.
So we are very thankful to Dr. Sangsu for giving us this opportunity and guiding us through our project. So let's get into the project. So these are the steps of our project: introduction, limitations, related work, proposed solution, experimental work, conclusion, and future research. So let's talk about the introduction of our project. So in this project, chatbots are becoming increasingly popular as a way to interact with businesses and organizations. So they can be used to provide customer service, answer questions, and even complete tasks. There are two main types of chatbots. The first one is rule-based chatbots, and the other one is machine learning chatbots. So the rule-based chatbots are programmed with a set of rules that they use to respond to user queries. On the other hand, the machine learning chatbots are able to learn from their interactions with users and improve their responses.
Coming to limitations of an existing chatbot, they have many number of limitations. One limitation is that they're often not very good at understanding natural language. This can make it difficult for users to interact with them in a natural way. Another limitation is that chatbots are often not good at handling complex queries. If a user asks a question, then the chatbot is not programmed to answer. It may be not able to provide a helpful response. Finally, chatbots can sometimes be frustrating to interact with because they can be repetitive or unresponsive. And coming to related work, limitations emphasized by Meshram. Researchers highlight that common chatbot limitations struggle with emotions, multilingual support, and common queries. Additionally, core NLP weakness like inflexible NER models hinder effectiveness. Chatbot performance directly affects brand perception, as noted by SAVE. And advanced LLM like ChatGPT 4, Palm show compromise like understanding social cues with potential for chatbot interactions. And coming to performance and customer convenience, the performance of a chatbot can have a significant impact on the customer satisfaction and also brand loyalty. If a chatbot is able to provide helpful and accurate information, customers are more likely to be satisfied with their experiences and then continue using the brand. On the other hand, if a chatbot is unable to provide helpful information or if it is difficult to use, customers are more likely to be frustrated and abandon the brand.
Social intelligence is the ability to understand and respond to the social cues of others. It is an important part of human communication, and it is also becoming increasingly important for chatbots that are able to understand social cues. Next slide. Our proposed solution is a conversational chatbot that leverages the power of Palm, Hugging Face embeddings, and LangChain. Palm, a large language model from Google AI, excels at natural language processing and can generate human quality text in response to a wide range of prompts and questions. Hugging Face embeddings provide a way to semantically analyze text, allowing the chatbot to understand the meaning behind the words a user types. Finally, LangChain bridges the gap between chatbot and databases, enabling the chatbot to retrieve product information and complete tasks.
So let's talk about the architecture of our project. So here you can see the graph, text analysis, and answer generation. First, the user inputs the question and it will be analyzed by Palm. And it will look into the semantic similarity sector where it matches with the already history, the questions stored in the history, and it will look at the few short examples for context. Then it will generate the SQL query based on the few short examples and trained data. With that SQL query, the Palm will run the SQL query in the DB using the LangChain. So after it executes the query, the results get retrieved by the Palm and it will be presented to the human as a human readable answer. Let's talk about Palm. So PaLM is a factual language model from Google. It is a very powerful language model that is capable of understanding and responding to complex queries. It is trained on a massive dataset of text and code, which allows it to generate different creative text formats and answer your questions in an informative way, even if they're open-ended, challenging, or strange. By incorporating PaLM in our chatbot, we can ensure that chatbot is able to provide accurate and helpful information to users.
Into Hugging Face embedding, these embeddings are valuable resource for natural language processing tasks. It provides pre-trained transformer models that can be used for a variety of tasks, including sentiment analysis, text summarization, question answering. In our chatbot, we will be using Hugging Face embeddings to perform sentiment analysis on user queries. This will allow the chatbot to understand the meaningful meaning behind the words and the user types, even if the user query is not phrased in a traditional way. LangChain, it's a powerful tool that allows chatbots to interact with databases using natural language. This means that users can ask the chatbot questions about products, place orders, and track the shipments using the natural language. By integrating LangChain into our chatbot, we can ensure that the chatbot is able to provide users with the information they needed and complete the tasks on their behalf.
Next slide. One of the challenges associated with training chatbots is the large amount of data required. To address this challenge, we propose incorporating few shot learning techniques into our chatbot. Few shot learning is a machine learning technique that allows a model to learn from a small amount of data. This is particularly beneficial for our project because it allows us to customize the chatbot for different domains and purposes without requiring a massive amount of training data. Next slide. Uh, Another challenge for chatbots is understanding non traditional phrasing. Users may not always ask their questions in a way that the chatbot is expecting. To address this challenge, we will use semantic similarity approaches. Semantic similarity approaches allow the chatbot to identify queries that have a similar meaning even if the wording is different. This will ensure that the chatbot can understand the user's intent and provide an accurate response, even if the user's query is not phrased in a perfect way.
So let's talk about the SQL query generation. Uh, While LangChain allows for natural language interaction with database, for complex tasks, we will utilize SQL query generation. SQL is a programming language specifically designed for interacting with relational databases. By using SQL query generation, we can ensure that the chatbot is able to retrieve the most accurate and relevant information in the database in response to user queries. Let's talk about the emotional recognition for personal interactions. To create a more natural and engaging user experience, our chatbot will incorporate emotion recognition. It is the ability to identify and understand the emotions of others. By incorporating emotion recognition, our chatbot will be able to tailor its responses to the user's emotional state. So this will allow the chatbot to provide more personalized and supportive interactions with users.
To the coming to the experimental scenario, to evaluate the effectiveness of our proposed chatbot, we developed an experimental scenario. In this scenario, users will interact with the chatbot and ask questions about products, place orders, and track shipments. So this is the code we have used. The We import the necessary modules from LangChain to use Google Palm as our LLM. An API key is provided for authentication with the Google Palm service. The LLM is instantiated with a temperature setting for controlling response creativity. To connect to the database, we import SQL database from LangChain and establish a connection to a MySQL database containing our product information. So we have taken the example of t-shirts here. Credentials and connection parameters are also provided here.
Then, for building the conversational chain, we created an SQL database chain to link the language model with the database. And then we enabled it to answer questions based on the database content. Then we initiated conversational buffer memory to give the chatbot short term memory for context. The conversation chain is created by combining the LLM database chain and memory, forming the core of our chatbot. Few shot learning for adaptability, it provides a few short examples like input and output pairs. These teaches the chatbot how to map the natural language questions to SQL queries and also generate the appropriate textual responses, which allows the chatbot to learn even with the limited training data. And also for importing embeddings to convert few short examples, we use semantic similarity. So it is for understanding nuances. Then we imported modules to Hugging Face sentence embeddings, and then transformed few short examples into semantic embeddings. And then we created a chroma vector store for more efficient similarity search. Uh, so we would use to store these embeddings for later use. A semantic similarity example selector is then created to help the chatbot find more relevant few short examples when faced with the new user queries.
So the few short examples are stored in the vector store using the chroma embeddings. Then these vector stores can be used later by the PALM to analyze the user queries. So here we store the embeddings into the vector store. Then we use the semantic similarity and uh, and the LangChain prompts to analyze the questions. Then if we can ask any question to the LangChain now, using the semantic similarity, it will map this question to the already existing questions in the few short examples, and it can understand how to generate a SQL query based on the few short examples. Then we have imported the MySQL prompt. Basically, this is a prompt which tells LLM to how to generate query, how to look at the SQL database, and for which questions, how to answer. All this, all this will be present in this MySQL prompt. So we are given MySQL prompt, and we have also included example prompt template where a question, when a question is given, how to generate answer. All these instructions were perfectly given within this example prompt. Then we have imported a few short template from LangChain where it can be used for input and table info and top key and history. Then we also embedded some memory into the our LLM so that it has some prehistory chart context so that it can answer questions perfectly based on the previous conversation. So at the end, we have embedded the LLM, which is our Google Palm. This is the database chain, which is our database, e-commerce database. And this is the few shot prompt where we have included all the few shot examples and semantic similarity embeddings and also the SQL prompt. And we have also given the memory where it can store the previous conversation and answer the questions based on the previous conversation. So let's run our Google Palm. So right here, I already wrote a question about Nike shirts. So let's ask the chain about the Nike shirts. So here I asked, I want to know about Nike shirts. It went into the database and ran this query, and it gave the answer. We have Nike shirts in red, blue, black, and white colors. Do you have a specific color in mind? Then I gave the spelling as BLUUEE, which is a wrong spelling. So people can use any kind of spellings and any kind of slang in the e-commerce website. So we are focusing on all those situations. So we gave this as blue color. So let's see if it can understand. So here it ran this query using the color blue. Even if you gave the wrong spelling, it understand it. So we have blue t-shirts from Van Heusen, Levi, and Adidas and Nike. What size are you looking for? So here we are saying like Nike, and we can ask like small size, something like that. So let's see. Yeah, we have 24 black Nike t-shirts in small size. Do you want to know about other sizes on all colors? So it clearly understand with the previous conversation. No, here we are saying, okay, no, I want red as a read. So let's see how it can depict this query. So it says now we have, as we are asking the red color now. It says we have 35 red Nike t-shirts in small. Now we are asking, yeah, okay, let's place the XS sized one. So XS is a very small. So there is one red Nike small XS size t-shirt in our inventory. Do you want to purchase it? Yeah. Now we are giving an order like yes, place one of it, which is not a completely grammatically correct English format. So let's see if we can understand this thing. So it's running the query. So yeah, let's see. One red Nike XS size t-shirt has been added to your cart. Do you want to purchase? Confirm checkout. See, we wrote the spelling wrong. Let's see if it confirms the checkout. Your order for Nike has been confirmed. See, we can place an order using our chatbot with any type of language, even with spelling or grammar mistakes or any type of slang. We can use our chatbot to place orders, and we can use this in any e-commerce. So, as a further research, we also include this is not included in our project, but we also included a voice recognition system. I just want to have a quick demo about it. Give a quick demo. Uh, let's run this. Yeah, so as you can see, I have implemented several speech recognition and audio libraries from Python where it can understand the user words as a speech recognition. So it simply acts like a virtual assistant where we can place it in a e-commerce shop, website, or also in the. I want to order one Nike red small size T-shirt. Yeah, maybe a blue XS size Nike T-shirt. So as I, yeah, so this is how we can interact with our chatbot. So let's get back to the PPT.
So here we have compared the existing chatbot with the chatbot which we have proposed. So here there are various features in which our chatbot is leading. So coming to the understandability, emotional understanding, multilingual capabilities, complex query handling, adaptability and learning, knowledge-based integration, social intelligence, and dynamic conversations. So by looking this, we can get a brief understanding like how the proposed chatbot is way better than the existing chatbots.
So, in conclusion, our proposed conversational chatbot offers a unique approach that leverages the strength of Palm, Hugging Face embeddings, and also a line chain. By incorporating these powerful tools, our chatbot can overcome the limitations of existing chatbot and provide more natural, engaging, and informative user experience. And few short examples it learns how it allows for the customer with minimal data. Semantic similarity ensures understanding of user intent. SQL query generation facilitates complex database interactions and emotion recognition, which personalizes interactions. We believe that our chatbot has the potential to revolutionize the way that business interact with their customers. So, in the future, we plan to conduct further research to explore how conversational AI can be applied to other domains and also to develop new features that will further enhance the user experience.
So let's talk about the future research of our project. So the future of conversational AI is very bright. We believe that AI has a potential to transform the way we interact with technology and with each other. In the future, we plan to explore the potential of AI in different domains such as education, healthcare. In education, chatbots can be used to provide personalized tutoring and feedback to students. In healthcare, chatbot could be used to provide patients with information about their condition and to answer their questions. So there may be users there. So in healthcare, patients the emotions of the patients may differ. In education, the emotions of the students may differ. So the chatbot has to understand the emotions of each user according to his problems, and it has to respond in accordingly as a human. So, for example, we could develop a chatbot that are able to generate creative text formats like poems or musical pieces. Additionally, we will conduct research on how to make chatbots more empathetic and supportive. By making chatbots more empathetic and supportive, we can create more natural and engaging user experience. Overall, we are very excited about the conversational AI, and we can also make this as a voice assistant, which can take orders in place of humans, maybe in restaurants, in e-commerce website, and any other like healthcare and also education industry. So this is the end of the project. So thank you, Dr. Sangsa, for giving us giving this opportunity.
Thank
Thank you.
you.